This is a correction video for the dot product from module 1.1.1 Einstein's summation convention. So, basically the dot product we remember from the high school, they will take the basically two kind of vectors and it will output or it spits out a scalar. And here we have tensors. So we'll take the kind of two tensors and it will spit out a scalar. And just to give you kind of a recall from the high school or from the bachelor's, we have, if we have two vectors like the C and D, and we have C dot D, these are two vectors. So of course they have a magnitude, and we can call it like in a form of C, and here C is basically the unit vector for C, and D is of course it has a magnitude and also has a kind of a unit vector. And what it does basically, it takes the magnitude of C and D and the cosine between the two unit vectors. So since in bachelor's in high school we already had kind of a let's say orthogonal systems. So if this was C and this was D, so D's angle usually was let's say half pi, for example, and therefore the cosine theta was 0. So if we had two vectors that they're basically orthogonal, their dot product was 0. But if there were not, for example, orthogonal, let's say that this was C, this was D, and this was, for example, pi third. So basically the cosine theta was half. So, and then we had the result for the dot product as a scalar. So it was a zeroth order kind of tensor. So now what we have is basically the two vectors. So we have A dot B. So that is A. Let me write it here. A dot B equals A I E I. So we have a magnitude and a unit vector dot Bj EJ equals to, so I brings the like the magnitude next to each other, EI dot EJ. So this equals, so now I try to expand this with I and j equal to 1, 2, and 3. So A1 BJ E1 dot EJ plus A2 BJ E2 dot J plus A3 BJ E3 dot EJ. Now this equals to, this is A1 B1 E1 dot E1 plus A1 B2 E1 dot E2 plus A1 B3 E1 dot E3. So basically what I did, I actually expand this in here. So this is the first line plus A2 B1 E2 E1 plus A2 B2 E2 dot E2 plus A2 B3 E2 dot E3 3. And this is basically this second term in here, and the third term plus a 3 b1 e3 dot e 1 plus a3 b2 e3 dot e2 plus a3 b3 e3 dot e3. All right, so and now we basically have a kind of an orthogonal kind of system, a right-handed one. So here we have E1 and then E2, and this is E3, and this is of course orthogonal, so these are mutually orthogonal. Therefore, what we have is basically, so from here, E1 dot E1, so if the two, they make a kind of, so this is E1, and this is, for example, E1 from A, for example, and this is E1 from B. So the angle theta is basically 0, and the cosine of 0 is 1. Therefore, this is going to be 1. But between E1 and E2 and E1 and E3, this angle is 0. Sorry, is 90 degrees, which gives the cosine theta as 0. So this becomes 0 and then 0. And then we have the same story here for 0. This becomes 1. This is 0. This is 0. This is 0. And this is 1. So finally what we get is basically A. So A1, B1 plus A2, B2 plus A3, B3. And if I want to write it in a kind of a tensorial form, then I have to write it as A, I, B, I. It becomes kind of a scalar. Or I can write it in a way like AI. I can use the kind of the delta, the current curve delta, AI, BJ, delta, IJ. So whenever I is equal to J, so then what I get is AI, BI, and then I get these values in here. Otherwise, it becomes 0.